Okay, so the unit circle is a circle with a radius of 1. Like, whoa, we need a pen. Okay, so 1 unit, 1 unit, 1 unit, 1 unit. So it has a radius of 1. Okay, and the reason why we really like the unit circle, the equation for the unit circle is x squared plus y squared is equal to 1 squared, which is 1. The cool thing about the unit circle is that any point on the unit circle, so if I have an angle like this, theta, then this x comma y point on the unit circle, we're moving over x and down y to get to the point. This is equal to the cosine of the angle, this angle, theta, comma, the sine of the angle. So cosine is x and sine is the y value of the point. All right, so sine, like I said, is the y value, so it'd be y over 1. Cosine is x over 1. The tangent is rise over run. So let's draw another example in the first quadrant, because that makes the most sense. Y, x, and 1. So tangent is rise over run, so y over x. And because of excluded values, x cannot equal 0. The cosecant would be the reciprocal of sine. So we get 1 over y, where y cannot equal 0. Again, cosine and secant are reciprocal, so this would be x. This would be 1 over x, where x cannot equal 0. And cotangent and tangent are reciprocals, so x over y, or y cannot equal 0. When y equals 0 or x equals 0 on these functions, we get vertical asymptotes on the graph. All right, we're going to sketch the graph of pi over 6. Okay, so pi over 6 is closest to the x-axis. It is technically 30 degrees. So I'm going to put my theta in here as pi over 6. Because I remember about 30, 60, 90 triangle rules, across from 30 is the smallest side, so 1/2. Across from the biggest angle, that's not 90, would be root 3 over 2. And across from my 90 degrees is a 1. So the sine of pi over 6, that would just be my x, or my y, 1/2. Technically, it's over 1 for the radius, so the y over the radius, which is just 1/2. So we can see that the sine, when our radius is 1, the sine ratio is just the y value. Okay, so the cosine of pi over 6 is is x over 1. Our x value is root 3 over 2. Tangent is a little trickier. It's y over x, so we get 1/2 divided by root 3 over 2. How do we divide fractions? We multiply by the reciprocal. So I'm going to go ahead and do that. Multiply by the recips, giving us, that cancels to make a 1, that cancels to make a 1. 2 divided by 2 is 1, so get 1 over the square root of 3. Y'all know that we need to rationalize, so I'm going to go ahead and multiply by the root 3 on the top of the bottom, giving us root 3 over 3. So that's a common ratio, that's a common ratio, that's a common ratio. Know them, learn them, love them. Okay, cosecant is, it's the reciprocal of sine. So once you get choices, you can either say it's 1 over my y value. So 1 over the y value is 1/2. Again, multiplied by the reciprocal, giving us 2. The other thing you can do is just look at the sine ratio we already figured out and take the reciprocal. Okay, so we'll do that for the next one. Secant is the reciprocal of cosine, so I know root 3 over 2 is cosine, so cosecant would be 2 over the square root of 3, but we got to rationalize, giving us 2 root 3 over 3. Again, pretty common ratio for us here. So cotangent of pi over 6 is the reciprocal of what? It's the reciprocal of tangent. Knowing that, well, really this 1 over root 3 is the tangent ratio. So I'm going to go ahead and reciprocate that so that my root doesn't end up in the denominator. So the reciprocal of cotangent would be root 3 over 1, which is just the square root of 3. Okay. All right, let's look at the next ones here. We're going to look at the unit circle. You should have already filled one of these in during class. So if I have a 45, 45, 90 triangle, 45, 45, 90, or pi over 4, pi over 4, pi over 2 triangle, we're going to go ahead and look at, we know the rule is x, and x square root 2. So, okay, so if we make our radius equal to 1, then 1 is equal to the length of our hypotenuse, which is x root 2. So x is equal to 1 over the square root of 2, which again we rationalize, which is root 2 over 2. So x is equal to root 2 over 2 and root 2 over 2 when our radius is equal to 1. A 30, 60, 90 triangle. We have 60, 30, and 90, or pi over 6, pi over 3, and pi over 2. The rules for those are x is the short side, 2x is the long side, is the hypotenuse, and x root 3 is the side across from 60. So again, let's make our hypotenuse equal to 1, or our value equal to 1. So that means that x is going to equal 1/2, and then x root 3 is going to equal 1/2 root 3, which we call root 3 over 2. So we use these ratios when we write in the coordinates in our unit circle. Okay, so let's go ahead and look at the first quadrant of our unit circle. We know that each one of these angles in radians is going to, first we have pi over 6 because it's closest to the x-axis, pi over 4 is the middle whisker, and pi over 3 is the biggest wedge. Okay, this one is pi over 2, and now we're moving in the second quadrant, so we're going to go pi over 3, pi over 4, pi over 6, and then pi. So we're one wedge, so we're only on 2 wedges of the 3. We've only gone 3 of the 4 and 5 of the 6. We talked about this in class. Okay, again, 1 extra wedge, so 7 pi over 6. We have over 4, so this is 5 pi over 4, and over 3. So 4 pi over 3, and then we get 3 pi over 2. Lastly, we have over 3, over 4, over 6, and 0 pi or 2 pi. All right, so we have 12, so double the 6 minus 1 gives us 11, double the 4 minus 1 gives us the 7, and double 3 minus 1 gives us 5 pi over 3. Okay, we're going to talk about really quick about how to get the coordinates. So this right here is a 30 degrees or pi over 6 triangle. So the side length here would be 1/2, and across from that would be root 3 over 2 on a radius of 1. So my x value is root 3 over 2. My y value to get to this point is 1/2. half. The next one is our 45, 45, 90 triangle. So I'm just going to erase these. Okay, so we're going to go here, here, here. We want to get the coordinate of this point. So how far over did we move? Well, if this is a 45-degree triangle, then this would end with a radius of 1. Then I moved over root 2 over 2 and up root 2 over 2. So root 2 over 2 over 2. All right, our last part would be, oops, I was erasing. All right, our last part is, let's get, ooh, that's not a pretty color. Wow. Sure. Okay, that's almost what I had before. Anyway, okay, so this is a 60-degree angle. So across from 60 would be root 3 over 2. And then across from 30 is 1/2, and our radius is 1. So my x value is 1/2, and our radius is our y value is root 3 over 2. This part, when I just move upward, my x value is 0, my y value is 1. When I just at 0, my x value is 1, my y value is 0. Okay. My x value is -1 and 0 at pi. My y value is 0, -1. So something to remember about the unit circle is that, so when my angle is, let's use this angle 60 degrees or pi over 3. So the cosine of pi over 3 will equal the x value of the coordinate. So it will equal 1/2. The sine of pi over 3 will equal the y value of the coordinate, which is root 3 over 2. All right, we're going to take a little pause, and I'm going to give you a unit circle in your notes. Okay, check out this fresh, beautiful unit circle. Okay, anything that divides by 6 has the same coordinates. It's just a different x, and the signs of the x and the y values are different depending on what coordinate they're in, or quadrant. Okay, so they're all the same. The pi over 4s all have the same coordinates because they derive from the same triangle. Same with the pi over 3s. Okay, so they all kind of use the same first quadrant triangles to figure out the coordinates for the rest of the circle. All right, next up, we're going to evaluate again at pi over 3 pi over 4. So 3 pi over 4, I'm going to look at where that is. That is in the second quadrant, so almost to pi over just pi. The triangle would be, the angle is here. Theta is equal to 3 pi over 4. I'm going to use a reference triangle of pi over 4, so for my first quadrant. So I know the side lengths are root 2 over 2 and root 2 over 2, but I'm moving to the left in the x, so it is a negative root 2 over 2. So my x is negative root 2 over 2, my y is root 2 over 2. So the sine of 3 pi over 4 is just the y value, root 2 over 2. Oh, my radius is 1. Okay. The cosine of 3 pi over 4 would be root 2 over 2, but to the left, so it's going to be negative. The tangent would be these two divided, so root 2 over 2 divided by negative root 2 over 2. So that would be -1. And this is 3 pi over 4. The cosecant of 3 pi over 4 reciprocate sine. So 2 over square root of 2 Go ahead and rationalize. Is 2 root 2 over 2. Cancels to give me just root 2. Luckily, secant is the same, so this is going to be root 2. Cotangent is the reciprocal of negative 1, and the reciprocal of negative 1 is negative 1. All right, so next, just some more features about trig functions. So we need to remember that trig functions are periodic, so they just continue on and on and on and on. So if you think about your circle, it can just keep opening up wider and wider with more and more and more and more and more and more rotations over and over and over and over again. We're going to end up in the same places on our unit circle, no matter where, as we keep going around and around and around and around. So 0, sine of 0 is equal to the sine of 2, equal to the sine of 4, is equal to the height at the sine of 6 pi and the sine of 8 pi, which in general, if we call this an angle t, the sine of t is equal to t plus 2 pi. So all of its coterminal angles. We've been talking a lot about this. The cosine of pi and 3 pi, 5 pi is equal to the cosine of 7 pi, 9 pi. So what am I doing there to each angle? I'm adding 2 pi times n. 2 pi times n. Need to add that n in there, up in the sign. Okay. So we're going to evaluate sine of 13 pi over 6 using our ideas of periodic functions. So I know that the sine of 13 pi over 6 is equal to the sine of, how many full rotations can I take out of 13 pi over 6? So 2 pi here. So 2 pi written with 6 would be 12 pi over 6. So how many 12 pi's over 6 can I take out? Just 1. So 13 pi over 6 has a coterminal angle at pi over 6. So I'm going to go back to my unit circle. Actually, I'm just going to draw it because that's even better. And be like, okay, pi over 6 right there. That means that the side length, the y side length is 1/2 at pi over 6. So the sine of 13 pi over 6 is equal to the sine of pi over 6, which is equal to the ratio of 1/2. Okay. All right, again, cosine of negative 7 pi over 2 is equal to the cosine of, see, we're dividing by 2 this time, so 4 pi over 2. How many times can I take out 4 pi over 2's? Well, see, let's just subtract them. It looks like we can take out that times 1, leaving us with negative 3 pi over 2 left over. So the cosine of negative 7 pi over 2 is equal to its coterminal angle, the cosine of the coterminal angle, 3 pi over 2. So we're going negative this direction, starting at 0, ending at 90, or pi over 2. That would be negative 3 pi over 2. Okay, so on the unit circle at negative 3 pi over 2, the coordinate is 0, 1, and the cosine has to do with the x coordinate, so the cosine of negative 3 pi over 2 is equal to 0. So the cosine of negative 7 pi over 2 or negative 3 pi over 2 is equal to 0. We move nothing left or right. All right, trig functions are also even or odd. So just remember, even functions are when f of negative x is equal to f of x, and odd functions are when f of negative x is equal to the negative output, so negative f of x. The cosine of negative t is equal to, I'll just give you this one, cosine of negative t is equal to the whoa, that was crazy, cosine of t, and because cosine and secant are reciprocals, then the secant of negative t is equal to the secant of positive t, which makes these even functions. Okay, sine and tangent and its reciprocals are odd functions. So the sine of negative t is equal to negative sine of positive t. Its reciprocal is equal to the cosecant of positive t. Tangent negative t is equal to negative tangent t. And cotangent of negative t is equal to the negative cotangent of positive t. So using our rules, if cosine of negative t is equal to 1/4, then cosine of t, let's see, it looks like when my input is negative, then I know that the cosine, well, things are going crazy today. Cosine of negative t is equal to the cosine of t. The cosine of negative t is 1/4, so cosine of t must be equal to 1/4 as well. So if the secant of negative t is equal to the secant of positive t, then I just remember that secant and cosine are reciprocals. So the secant of t is equal to 4. And so the secant of negative t would equal 4. So it's just the reciprocal of cosine as well at that point. All right, lastly, here's a little radian measure. We're going to look at the sine of 3 radians. So I'm going to look at on the circle, opening up to 3 right here. So I have an angle that moves from our x-axis to 3. That's a very bad line. Okay. So how far is sine x or y on the unit circle? It looks like our radius is equal to 1. So how far over and up are we moving? We're going to guesstimate. So I moved almost all the way over to 1, so like 0.97 maybe. And actually, is the x the sine or is cosine the y? So remember, sine is equal to the y and cosine is equal to the x. So I actually need to take this business over here and move it as my cosine value. The sine, how far did I move up to get to 3, would be like 0.2. 0.2. So this point is 0.97, negative, comma 0.2, about. Okay, 5.57. So this time I'm going to move all the way from here all the way to 5.57. So we have starting at 0, moving to 5.75. I think I said that transposed. Sorry. So my x is equal to a little more than 0.8, so 0.88 maybe. Positive, and my y is equal to, let's see, you mean negative 0.5. So the sine is my x, so it's going to be, sorry, I said that backwards. So sine is my y, so negative 0.5, and cosine is the x value of the point, so 0.88 positive. So the x in each ordered pair relates to the sine of theta, of your angle. Actually, we can write it out. And the y, I don't know why I keep saying these backwards. I apologize. Okay, the x value relates to the cosine, you should know this from the Ferris wheel, of your angle. And the y value relates to the sine of your angle. The sine ratio, cosine ratio, sine ratio. That was really long, so I'm going to split this up over 2 days.